Hi guys, and welcome to another video. Today we're going to be looking at maximum and minimum values. The question that we're going to be looking at is from the February-March 2016 paper, and it says a soft drink can has a volume of 340 cubic centimeters, a height of h centimeters, and a radius of r centimeters. The most important thing for us to remember in this particular section is that at your maximum or your minimum values, and you can see it's down here, that the derivative of our function is going to equal to 0. So we need to take our derivative of whatever our function is and equate it to 0. Remember that in this question we can be given a question as a word problem, we can be given a question as a 2D problem, a 3D problem dealing with volume, etc., etc. Now let's just focus on this particular problem. So remember that for maximum and minimum, the derivative of the function must equal to 0. Alright, so it says express h in terms of r. So always read and look at what you are given in this particular question. It says that the volume is 340 cubic centimeters. We must express h in terms of r. So what we're going to do for 9.1 is we're going to say volume of a cylinder is equal to, remember, it's a right prism, so it's going to be pi r squared times height. So the area of base times the perpendicular height. Now let's substitute what we are given. 340 cubic centimeters equals to pi r squared times height. Therefore, we said express h in terms of r. So therefore, h is equal to 340 over pi r squared. Okay, so that answers the first question. H is equal to 340 over pi r squared. In the second question, it says show that the surface area of the can is given by A of r equals to 2 pi r squared plus 680 r to the minus 1. Now, when it comes to answering this type of question, it's important for us to know our formulas for volume and surface area of our right prisms. Now, that's quite important for us to be able to know. Now, in this particular question, what will be the surface area of this particular cylinder? Well, if we break it down, it will be as follows. The top will be pi r squared, because remember that's a circle. The bottom is also circular, so that's also going to be area of a circle, pi r squared. And the size of a cylinder is 2 pi r h, 2 pi r h. And if we put all together, the total surface area will be pi r squared plus pi r squared is 2 pi r squared. So let's answer that. So for 9.2, we can now say that A of r is equal to 2 pi r squared plus 2 pi r h plus 2 pi r h. So now remember that in the first question we wrote h in terms of r. So now we're going to substitute. Therefore, A of r equals to 2 pi r squared plus 2 pi r, and let's substitute what we had for h, 340 over pi r squared, which is equal to, let's simplify, it will be 2 pi r squared. So pi cancels with pi, r and r squared, so 1 r from here and 1 r from there. So basically we're going to be left with 2 times 340 is 680. 680 all over, what are we left with here? R. Okay, so 2 times 340, 680 all over R. So if they want us now, it says show that A of r equals to 2 pi r squared plus 680 r to the minus 1. So we can write it like that now. If we take the r to the top, it will be 2 pi r squared plus 680 r to the minus 1. So that is our solution. The next question says determine the radius of the can that will ensure that the surface area is a minimum. Once you see minimum, then you're going to take the derivative of your function and equate it to 0, and you're going to solve. Okay, so this is a of r. So a of r equals to 0, and we're going to solve for r. R is the radius. Okay, so let's now find the derivative of our function. So remember that when you find the derivative of your function, make sure that each term is in the form kx to the n, because we're going to be using the rule to find the derivative of the function. So each term is in the form kx to the n, and remember the rules for differentiation: no r terms in this case in the denominator, no roots, etc. So therefore a primed r equals to 0. Find the derivative. 2 times 2 is 4 pi r, so it will be 4 pi r. 2 times 2 is 4 pi r. We'll be subtracting 1 from there, and here it will be minus 680 r to the minus 2 equals to 0. Okay, minus 1 times 680 is minus 680, and subtract 1, minus 1 is minus 2. Okay, so I'm simply differentiating using the rule. Now let's solve for r. So we're going to get 4 pi r equals to 680, and at the same time let's take r to the minus 2 to the bottom. It will become r squared. So now let us cross multiply and make r the subject of our equation. So therefore we'll get r cubed. R times r squared is r cubed equals to 680 all over 4 pi. Therefore r equals to, we're going to take the cube root of both sides. So the cube root of 680 all over 4 pi, and let's see what that's equal to. So let's use our calculator. So the cube root of 680 all over 4 pi. Pi equals to 3.78. Round off to 2 decimal places. So it's 3.78, and our units that was given to us is centimeters, so we write down centimeters. And that's our solution. Let us just make sure that you know your formulas in this particular section of 2-dimensional and 3-dimensional figures for volume and for area, and you should be fine. So the basics of this particular section is we need to be able to formulate an expression in terms of one variable only, and remember, for maximum and minimum values we need to find the derivative of that particular expression and equate it to 0, solve for our variable. Okay, if you haven't subscribed already, please subscribe to my YouTube channel, JR Maths. Also check out all the videos on jrmaths.com. I'll catch you in the next video.